and we are going to perform lab number 6 of DSP. So here in task 1 we have to find the decimated and the reconstructed signal. So we have a signal x is equal to this, and then we have a decimation factor m is equal to 2. We divide the signal into even and odd samples, here you can see, and then we calculate the DFT for individual even and odd sample. So here you can see, then we merge both of these samples using this formula, and we display the result using display function in MATLAB. Here we display the original signal, here we display the decimated signal, and here we display the reconstructed signal. So by running this code, we are getting the output as original signal, this, and then the decimated signal 1357, and then the reconstructed signal. Here you can see column 1 and through column 5 you can see that. So in task 2 we have our given signal this, and then in decimation factor m is equal to 2. Again we divide the signal into even and odd sample, then we calculate the even and odd sample DFT using this formula, then we merge the signal same as in we did in task 1. Then we compare the DFT with standard MATLAB function. Here you can see display DFT of x1 and FFT of x1 and decimated x1. So by running this code, we get here output as original signal, decimated signal, and DFT of x1. In task 3, we have two signal x and y. Here you can see. Then we have decimation factor, which is 2. We divide our signal into even and odd sample. Here you can see for x 1:2 and x is equal to 2 ranges to 2, and then y is 1 ranges to 2 and same. Then we calculate DFT for even and odd sample separately. Here as you can see, we use this formula to calculate DFT and FT. Then we merge our signal using this formula. You can see here n is the length of x is equal to 0 and y is equal to 0. Then we display the original and estimated signal using display function. Here we display the original signal, here we display the decimated signal, and then we compare our both signal DFTs with standard MATLAB function. So by running this code, we getting output as you can see here DFT of decimated Y signal, this, and decimated of X here. So in task 4, we have a input signal x is equal to this, and we calculate the frequency representation using myFFT function. Then we compare it with standard MATLAB function, and then we display the results. So here, this is our MATLAB FFT, you can see, and this is our column 6 my FFT column. This is our output. So in task 5, we have a signal w, x, y, and z. Then we calculate the FFT using myFFT function we already saved, and then we calculate the FFT using standard functions here. Then we compare our result with FFT of myFFT. Then we here display our signal as signal y, custom function, then we standard function, then signal of z, then custom function and standard function. By running this code, we getting the output as this. See, this is our output. We have custom function, we have our FFT compared with FFT signal y and signal z. So this is our lab number 6.